All right, so we've got numbers, we've got strings. Now let's talk about Booleans. The third data type in Python isn't a number or a string. It's called a Boolean after George Boole, and it can be one of two values, either true or false. It may be seeming odd to have a data type for something that can only be true or false, but it's very efficient because it's just a single bit, the smallest amount of storage in the computer. So in Python, you can store true or false in a variable. For example, let's look at this one, x equals true, or maybe x equals false. True and false are Boolean because they're not enclosed in quotation marks. Normally, a string has to be enclosed in quotation marks, but this isn't a string, it's a Boolean. And it's certainly not a number. So the initial capital letter is required. You can't do it lowercase, like in JavaScript. Capital T, capital F has to be written that way. True, false. All right, let's talk about operators. Operators are not data types. So we covered 3 data types: strings, numbers, and Booleans. Operators are a little different. It's helpful to think of information as being one of the following data types: number, string, or Boolean. You also use computers to operate on that information, meaning you do any necessary math or comparisons or searches or whatever to help you find information and organize it in a way that makes sense for you. Python offers many different operators for working with and comparing types of information. Let's summarize them for future references without going into great detail. Whether you use an operator in your own work depends on the types of apps you develop. Let's just see what's available. Arithmetic operators. So these are for doing arithmetic. Here they are. Add, like 1 plus 1 is 2. Subtract, like 10 minus 1 is 9. Multiply, which is this asterisk. 3 times 5 is 15. 3 asterisk 5. Division. 10 divided by 5 is 2. Modulus, so this is the remainder. So 11 mod 5 is 1 because 11 divided by 5 is 2 remainder 1. So the 1 is the remainder. Exponent is double asterisk. That's very different from some languages. 3 asterisk asterisk 2 is 3 squared, which is 9. Floor division. This is division with the non-remainder part. I guess it's called the dividend, I think. 11 / 5 is 2. So again, we went through all of these. So integer division, anything after the decimal point is truncated. And it does not round. So 9 divided by 5 is 1, not 1.8 and not 2, but just 1. All right, so there's some comparison operators. Comparisons can make decisions as part of doing their work, but the decisions aren't judgment calls, they're just specific absolute facts, and here are the comparison operators. Less than or equal to, greater than or equal to. Notice this one, equal to, which is double equals. To make a comparison between two things, you have to use double equals. Exclamation point equals is not equal to, and again, you have to have two things. You have to have something on the left and something on the right. These are comparison operators. They compare two things. Object identity is, and negated object identity is not. The first few are self-explanatory. We won't go into details. The last two are tricky because they concern Python objects, which we haven't talked about yet. We don't want to talk about them just yet, so don't worry about that. The Boolean operators, they work with Boolean values like true or false. So or, and not. Or has a natural language, either x or y is true, and means both have to be true, and not is the negation. X is not true, not x. So always put white space around operators. You want to use spacebar before the operator and after. Here's a simple example. Num equals 10. We put a space before num, after num, and then before equals, and then also after the equals and before the 10. Num equals 10. We did the same thing here. If num is greater than 0, print positive number. Else, print negative number. That kind of makes sense. We store 10 in this variable named num. if we'll check to see if num is greater than 0, that's the comparison operator. If it is, it'll print positive number. If it's not, it'll print negative number. So if we change this code to say num equals -1, it'll print negative number because it'll check, is the num greater than 0? No, it is not. It'll print negative number. Num is a variable name. Operators will operate on the variable and compare the variable to this, the number, which is sometimes called a literal, because it doesn't change. A variable changes, a literal doesn't. So is the num greater than 0? In this case, it's yes, it's 10. All right, creating and using variables. Variables are a big part of all computer programming languages and Python. A variable is a placeholder for any information that may vary or change. Once again, a variable is simply a placeholder for information that may change. For example, when you go to Amazon's homepage, you see your name right there, right? This guy's name is Alan. And the date you became a customer. Customer since 1996. Wow, OG. Both of those pieces of information are variables because it depends on who signed into Amazon. If I sign in, it'll say Martin. That's a variable. Not everyone who goes to Amazon is named Alan and has been a member since 1996. Amazon can't make a custom homepage for every one of its users. Most of what's on the homepage is literal. Everyone views it will see the same stuff, but the information will change depending on who is viewing the page, and that information is stored in a variable. For example, like name. In your code, a variable is represented by a variable name rather than a specific piece of information. Here's another way to think of it. Anytime you buy one or more of a type of product, the extended price is the unit price times the number of items you bought. In other words, quantity times unit price is extended price. Quantity and unit price are variables because no matter what numbers you plug in for quantity and unit price, you get the correct extended price. If you buy 2 turtle doves for $1 a piece, your extended price is $3, 3 times 1. If you buy 3 turtle doves. If you buy 2 dozen roses at $1.50 per rose, it's $36, because 1.5 times 24 is 36. So variable names have specific rules. A variable name must start with a letter or an underscore. After that, you can use letters, numbers, or underscores. Variable names are case sensitive. Variable names cannot be enclosed in quotation marks. You should only use lowercase names in variables and an underscore to separate the letters. You can also use camel case. Camel case is something that looks like this. You don't have any underscores, you just capitalize new words. Some people really don't like camel case. So to create a variable, this is really interesting, and now you're going to be a real coder. You can type variable name equals value. Variable name is the name you make up, like age or name or whatever. You can use X or Y. Some people do. I wouldn't do that, though. I would use names like quantity, unit price, sales tax, username, so you can remember what's going in there. The value is whatever value you want to store. Remember the 3 data types you learned: number, string, or Boolean. And this is maybe the most important thing of the night. The equal sign is the assignment operator. Drill that into your head. The equal sign is the assignment operator. It assigns the value on the right to the variable on the left. It is not a comparison operator. The comparison operator is equals equals. This does not mean is x equal to 10. No, this means we're taking 10 and we're putting it in the variable x. We're assigning the value 10 to x. X is the assignment, equals is the assignment operator. User underscore name equals Alan. We're assigning Alan, the string Alan, into a variable named username with an underscore. So we can manipulate variables. That's what most of computer programming is about. It's about storing numbers or values of any kind in variables and then manipulating the information with operators. I really want you to use this term a lot. There's operators and variables. Let's try some simple examples. Quantity equals 10. Unit price equals 1.99. Let's go here. Extended price equals quantity times unit price. So that's 10 times 1.99, right? So let's try print extended price. Let's see what happens. It prints 19.99 because there were 10 things at 1.99. What if I made it 100 things? Would that work? There it is, 199.0. What if I change the price? What if I jack the price up to $50? That should be the new price, right? Python, run the file, and now you have $5,000. That's how you make real bread, but that's a whole other story. We raised the price. Say it was $18 before, and you're selling 2,000 pills. Quantity, let's change that to number of pills. Unit price was what, $17.50? We got to change this here. Number of pills. And let's run that again. And you can see the revenue was $35,000, but we want to change that. Let's change that to $7.50 unit price. And now the revenue is a lot more. It's 1.5 million, right? That makes more sense. How do we run? Right-click hello.py. Oh, you already know 𝗘𝗢𝗢𝗐, and run Python file in terminal. All right, so that's, is there a shortcut for terminal? It's control backtick or control tilde, which is right next to your number 1. All right, so you can save your work. Right-click hello.py and hit run Python file in terminal, and everything works out. So you can just change the number instead of changing the whole app. Proper syntax is important in programming. I think you guys know that. You have to do variable equals value. You can't do value equals variable. 10 equals x does not work. You'll get an error message. You got to follow strict syntax rules. That's what makes programming a little bit hard sometimes. The computer can't understand what you mean, right? In Python, a line of code ends with a line break or a semicolon. Let's try this example. Interesting. First underscore name equals Sarah. Okay. Last underscore name equals Shkreli. Okay. Now we're going to print first name, last name. Let's run this program. We're going to see Sarah Shkreli. But if we wanted to, we could put this all in one line with a semicolon, and we'll get the same result. And in fact, if we really wanted to, we could put everything on one line with another semicolon, and we'll still get the same result. Notice the variables have 2 words separated by an underscore. Again, that's the Python convention. You can also do camel case, which would look like that. If you really wanted to, you could do it like that, but I don't recommend that. Don't start a variable with a capital letter, only in certain scenarios. All right, so code blocks, very important. So let's again look at x equals 10. Now we're going to do if x, and remember, equals equals is the comparison. This does not mean assign 10 to x. That's what this line is. This means, does x compare, and how does it compare to 10? And we're going to use the colon. Isn't that weird? You put the colon down, and then you have to indent. You can press tab to indent. And we're going to type print x is 10, if that's true. And we can also change it to 0, and we'll say, well, x is 0. But I can also write whatever I want. I can write x is the moon landing, and this will run and print the moon landing, because the program isn't necessarily smart. It's only as smart as you are, right? So I can have completely legal code but it doesn't make a lot of sense. It says, well, if x compares and is equal to 10, it'll print x is the moon landing. But I can also make a mistake and say it can print x is 9, and this will still print because it is just the string. But notice what I did down here. It'll print x is, and then it'll actually print x without the quotation marks. We're referring to the variable x. So let's see what happens if we run this. I run it and it'll say x is 10 because it looked at x and said, well, is x equal, not assignment, but is x equals to 10? Equal? Yes, it is. So it ran this. And if I change this, there's no logic in here. I could say x is 9. It will still run and say x is 9 because it's just going to print whatever. I could say SBF is innocent, free my dog. And it'll run, and that's exactly what it'll say. It'll say what it said, even if it's wrong. It'll say exactly what you want it to. There it is. Now let's change x is 10 on the assignment operator to 9. So x equals 9. So this is false. X is 9. 9 equals 10? False. So it'll go to else, and it'll print x is, and notice it'll print what's inside of x, which is really cool. And it printed 9. And it printed 2 spaces, so I deleted one of the spaces, and now it prints that space perfectly. So if I put 5 in here, it'll print 5. If I take out this x, what do you think will happen? Will it print out the value of x? No, because I deleted it. So it just says x is. If I wanted to, I could write something like x is not 10, which is true because x is 5. So it'll type x is not 10. If I change it back to 10, it'll go back up here, make the comparison, and say, okay, that's true. So x is 10. If I change to x is 100, x is not 10, so it'll go to else and print x is not 10. And I also change it to say x is not 10, but it is, and then I do comma x and print x. So it says x is not 10, but it is 100, because it looks at what x is. So this is how you play with variables in Python, and this is going to be really, really, really important as you learn Python. The 2 equal signs means is equal to in Python. It's used to compare values to one another to see if they're equal. That's different from just 1 equal sign, which is the assignment operator for assigning variables. The first line, x equals 10, is just a line of code. Next, if x equals 0, test to see whether x contains the number 0. If it does contain 0 and only 0, the indented line, notice the indent, will run. It'll execute and it'll print x is 10 in this case, or x is 0 if we change it around. But if it does not contain 10, it'll skip this indented line and the else statement will execute. And we can also add a final line in here, print all done, and that will print no matter what because it's not indented. But if we indented it, what would happen? It'll only print if it's part of the else. So if we change this back to 10, will it print all done? I don't think so. It did not print all done because all done is part of the else. We know it's part of the else with the indentation. So if we remove the indentation, it'll print all done. So indentations matter quite a bit in Python. You'll learn about the specifics of indentation as you progress through the book. For now, just remember that indentations are very important, so be careful when you write them. Wow, we're 80 pages into this book. It's only 700 pages, so we're doing great. The exercises you just completed explain how to type, save, run, and change an app, save it again, and run it again. That's all you'll be doing with any kind of software development in any language, so you should practice them until they become second nature. But don't worry, you don't have to do this one chapter over and over to get the hang of it. You'll be using these same skills throughout the book as you work your way from beginner to 21st century hotshot developer. So that's it for book 1. We did great. Congratulations, everyone. There's only 7 more of these. So we did 1/7 of a whole Python book. Really impressive. Book 2, maybe we'll do some other day, is called Understanding Python Building Blocks. And again, it's only 6-7 chapters, so it's like similar to the first book we just read. And again, I know that you don't feel like you have a ton of skills just yet, but Rome isn't built in a day, and it takes a little time. And hopefully I whet your appetite a little bit. I do think learning Python is really important. I think it's crazy if it's 2023 and you don't know Python, you should really learn it. It's really easy and it's become really, really valuable. And there's a lot of important things you could do with Python. So I really strongly suggest you do learn it. And this book is pretty good for a beginner's book, but there's other books, of course. And you can read any of them. It doesn't really matter. You can also don't even need a book. You can go on YouTube. You can watch this. You can go anywhere and learn Python on YouTube, on different websites. There's boot camps. There's free ones. There's all kinds of paid ones. There's all sorts of lessons to learn Python. And I think it's really, really important to do so. Whole numbers, decimal points, strings, booleans, dates and times. So this is the first chapter. And again, there's a lot to this. So we have a lot to do. And this probably would take maybe 6 hours or so, maybe more. So this is a really big book 2. But I do think it'd be worth your time. Book 4 is using AI. So we're basically done with Python after book 3. Book 4, neural networks, machine learning, and AI. So this pretty quickly moves on to some cool stuff here. So it's a nice book for that reason. You get a taste of AI really quickly, which is pretty cool. And it's real AI. Like there's a lot of details in there that are really cool. Book 5 is data science. Short, really short, 40 pages. Maybe take an hour. Book 6 is about hardware, which I would probably skip. This is for working with Raspberry Pi, which is a really unique tool. Not something I think we necessarily want to do. If you want to do that, that's all you. Again, if you like that kind of stuff, that's great for you. Book 7. So I only would read half of this book. But if you like robots, go for it. Nobody's going to stop you. And you can even use AI with robots. So I would skip chapters 6 and 7 for me, and then that's the end of the book. So really short book, to be honest. I think we can hammer it out in a couple more videos. And then we could read more complicated books about Python. So I hope you enjoyed that. You get a little taste of what Python's all about.